Welcome to my CEH Chapter 7. In this chapter, we're looking at sniffers, session hijackers, and denial of service, or DOS. The objective is, after reading this chapter, we should be able to define sniffers and how they're used, describe active and passive sniffing, know sniffing tools, explain session hijacking, and explain what a denial of service is. So, sniffer. A sniffer is a program that could be used to collect information that goes through the network. We can place a host network card in promiscuous mode or monitoring mode, and it will collect all packets that the system sees, not just the one addressed to it. We can do this one of two ways. Passive. In passive, the sniffer is performed on a hub. Not common in the current network environment, but is a possibility. Active. This is where sniffing is performed on a switch network, and we have to normally configure it on the switch using some type of port mirroring or port monitoring. That way, all data that the switch processes will be sent to its normal destination as well as to the mirrored port. Sniffers operate at a data link layer. So active sniffing, the attacker must be either on the local network or at a point where the traffic passes through it. Overcoming sniffing limitation on a switch network is things like MAC flooding and ARP poisoning, among some things. Again, active sniffing is a very common security procedure, so that we can dissect and monitor all network traffic. So address resolution, or ARP. ARP resolves known IP addresses to unknown MACs. ARP communication consists of two messages, a request and a reply. It does not verify the responding device is who they say they are, so there is no authentication. And ARP cache stores the IP addresses, MAC address tables, as well as the time of the entry. If we run an ARP-A at the command prompt, we can see the ARP cache. ARP poisoning and flooding. That's when we start sending phony ARP requests or replies to switches in an attempt to distill traffic or to steer traffic to a sniffing system. Some of the tools we can use could be like UFSoft or UFSoft Sniff or ARP Spoof or EtherCap or Canonable or Wendian Spoof. I mean, lots of different tools that are out there. MAC flooding. This is where we seek to overload the switch CAM, or the content address memory. And we do that so that the switch can't process new MAC addresses. Frames start flooding on all ports. Again, one of the drawbacks is it generates a lot of traffic. And it normally requires a second machine so that we could perform captures. Tools that do that could be like ether flooding or SMAC or SMACOV or things like that. Also dealing with this MAC flooding, we could also start DHCP snooping or starvation so that we run out of IP addresses. Tools for sniffing, a very common one is Wireshark. And we get to be able to display the data in multiple types of views, like a summary or detail or the hex. TC dump, WinDump, OmniPeak are all tools. Wireshark and TCP dump and WinDump are very common ones. Countermeasures is implement port security. Don't just turn it on, but turn it on and configure it. So configure each switch with a MAC address for the device allowed to send and receive traffic. We could also do something called dynamic ARP inspection, and that's possible for Cisco devices. That way, it actually verifies sending and receiving MAC addresses. Very, very important. This allows us to restrict IP traffic on untrusted layer 2 ports. Can be very time consuming for large networks, but better security, maybe use encryption like IPsec or VPNs or some type of PKI infrastructure. Software could also be like ARP Watch or build static ARP entries. But again, that's very time consuming. Another thing is this concept called session hijacking. And this deals with the weakness in TCP and network communication. And that's where we can actually hijack a session to interject packets. Normally, the general steps are identify an active session, predict the sequence number, take one of the parties offline or get them out of the communication, and then take control of the session. So if you're trying to do a connection, a secured connection with like a web server, because you want to do checkout, what ends up happening is if you're able to redirect the traffic from your PC to the server for the web, you could actually redirect your traffic from your PC to a infected server instead. Not that you'd be doing it to your PC, but I mean your victim machine. Identifying an active session, first step. So it's easier if an attacker and victim are on the same network segment, though it's not a requirement. This helps. Again, normally it's going to be active sniffing. Challenge tasks when they're on a different segment. Still possible, just harder. So you need to do a blind sequence number prediction, and that may or may not work. The attacker can send package to the server to sample a sequence number to help get it. Remember in TCP, we actually having many things that are based off of that sequence number. So if you have the sequence number, you can pretend to be who you say you are. So every byte of data transmitted with TCP does have a specific sequence number, and that's used to keep track of that data reliability. That it's connection oriented, so it's reliable. But because of that reliability, we can actually interject data because of it. All the attacker needs to do is predict the appropriate sequence number so that you can interject a packet before the session ends with the appropriate sequence number, and bam, it's in. The prediction number, or the prediction for the sequence number, is heavily reliant on the operating system, but we can use tools such as Nmap or Ettercap or Hunt to help predict that sequence number. So remember, the attacker's goal is to take the user offline after they predict the sequence number. That way, they can actually interact with the victim. Things like a denial of service or source routing attacks or tricks at servers that the hacker is a legitimate user are all possible connections here. Application layer hijacking, again, very common, but here we're looking at things like man-in-the-middle attack or man-in-the-browser attack or client-side attack. The objective here is to steal or predict a session token so that you can trick or pretend to be a legitimate user. The session hijack tools, again, are Ettercap, Hunt, IP Watch. I mean, there are plenty of tools out there. So preventing session hijacking, there are two main methods, detection and prevention. Detection is a lot harder, but I mean can be done. Prevention, normally you limit incoming connections, reject IP packets that originate from a local address, use encryption, don't use open standards. What I mean by that is insecure standard like FTP or Telnet, don't use. Use something like secure FTP and SSH instead. Moving on is denial of service, and this can be done in many different ways. We could be denying us services through bandwidth consumption, just continuously trying to clog the bandwidth, or maybe opening several sync flood attacks, meaning we start opening up handshakes and we don't actually terminate them, so our end devices start getting a lot of open connections. And some of the programs and applications used to do this could be like Land or Teardrop or Ping of Death, anything that will consume bandwidth and have the ability to continuously open up sync requests. You can actually also distribute this using a distributed denial of service attack. Normally comes in two phases, a pre-attack phase and the actual attack phase. In the pre-attack phase, the attacker compromises other computers, act as a master or a zombie. That way they can spread the load across multiple computers to target one device. And the actual target of that one device is the attack phase. There are two main components for a DDoS attack, software and the hardware. The software is going to be the client software, the daemon software, while the hardware could be the masters and zombies and our possible victim. So with our DDoS tools, we have to look at some of the tools like Torino or TFN2K or WinTorino or Shaft or Trinity. Those are all very common DDoS tools, and each has very specific characteristics that operate at specific ports. This list continuously changes, so that's why I'm not going over all of them, because as they get very common, they start getting blocked. Botnet, again, that's where we can distribute that load, and that's a collection of infected PCs that are controlled by a hacker and normally used to cost money or to sell to other people. That way they can sell access to that botnet, so that botnet will then use its resources to DDoS attack a specific target. Some of the well-known botnets could be like Zeus or Citadel or Storm or Mariposa. Again, several huge botnets, and it's very common, and they're growing in how common they are, sadly. So our DOS or DOS attacks or DDoS attacks, botnets, the big thing here is we have to use things like IDSs, understand how we filter our outbound or egress traffic. Maybe look at only allowing necessary traffic. Make sure that things are up to date. Maybe look at bandwidth filtering or bandwidth limitations. Get rid of all non-essential services. Close all unused ports. And most importantly, understand the concept of least privileges and enforce policies. That's actually all I had for this chapter. I want to thank you very much.